Hello, Algebra 1, it is Mr. Knight coming to you live. Not live, it is pre-recorded, but I'm coming at you recorded from my classroom. We're going to do Level 3 and 4 review. Level 3 was percentages of time and how to convert a percent to a decimal. And then Level 4 was reducing fractions. So here are our skills today, okay? So how to move decimal points quickly. Should be converting percents to decimals. Okay, I correct it later on. Divisibility rules for numbers and reducing fractions. So let's get going with skill number 1, actually moving the decimal point. You can have full control over moving your decimal point. In fact, all it is it's just multiples of 10 to move your decimals. So there's two things that determine it. So the number of zeros tell you how many times we move our decimal point. So for example, if I take the number 1000, let's take the number 1000. I have 3 zeros, so I would move my decimal point 3 times. Okay? And then multiplying or dividing tells us which direction, which we're going to go over here in a little bit. Okay? So if we are looking at this number right here, 430.212, there's a couple things we can do, right? So I'm showing you examples of multiplying by 100 and dividing as well, and kind of what direction the decimal point is going. So we're starting with the same number over here, and for this first instance, we're just multiplying by 100. So I'm multiplying by 100, so I notice I have 2 zeros, so I should expect my decimal to move twice. And it looks like it actually does, right? I get 430, or I get 43,021.2, okay? Because that decimal point moved over twice, right? 2 zeros. Again, I'm dividing by 100, but I still see 2 zeros, so I know my decimal point's going to move twice. In this case, though, because I'm dividing, I'm doing the opposite of multiplying. So I'm actually looking at this, I'm going the opposite way. I'm going the opposite way. And I end up with this guy right here. You can actually check using your calculator. You could take this number and multiply by 100 or divide by 100, and you should get the same exact thing. Okay? But I'm not even using a calculator. I'm hands-free, baby. So I'm not even trying to do that stuff. Look right here. Now we're multiplying by 1,000. Again, I'm probably going to have to move 3 times. There's 3 zeros. And that's what ends up happening. I go to the right 3 times, and I just tacked on a 0 just to see where that decimal ends up going, okay? But this part is not really necessary, but I wanted to show you. So looking at this, if you're noticing, right, when we multiply, we're going to the right. When I divide, I'm actually going to the left, and that is part of our rules. That's part of our rules right here. So if I am writing down my rules, I know that if I multiply, I'm going to the right. If I divide, I'm going to the left. And you can see that with the math, and you can verify with your calculators. And that's it. It's just multiples of 10 that are determining this. So if we continue on, I want you to try, without using a calculator, I want you to try both of these right here. First one, 821.33 times 10. I want you to tell me what that number would be without a calculator. Same thing with number 2, except this time we're taking that number and we're dividing by 1,000. And go. And so, welcome back. Alright, if we're multiplying by 10, my rule tells me I'm going to the right. And there's only 1 0, so I'm only going 1 over, so I should get 8,213.3. And now here, I'm dividing, so I'm going to the left. How many times? 3 times, right? 1, 2, 3. We need some kind of placeholder. So my answer is 0.41122. And that's it. That's all we got to do. So this skill is actually very useful when it comes to converting percents to decimals or decimals to percents. It's really nice because this brings us to skill 2, converting percents to decimals. Converting percents to decimals. A percent, guys, is a decimal multiplied by 100. That's it. Okay? Any number you could think of. Think of it. All right, you got it? All right, I thought of one too. 432. Okay, that's my decimal. Now I'm going to multiply by 100. All right? Well, if I have 432 and I'm going to multiply by 100, well, I'm multiplying, I'm going to the right, and by 100, there's 2 zeros, so I'm going twice. So there we go, 43,200%. Okay, you got kind of messed up along the way there, but hopefully you're kind of starting to see the idea, right? It's just a decimal multiplied by 100. That's it. That's all it is. So if that's how I get a percent by multiplying by 100, what if I wanted to go the other way? What if I started with my percent and now I want a decimal? Well, if to go from a decimal to a percent, I multiply by 100. Well, I just showed you up here earlier, you can go the other way by dividing. And we're going to divide by 100, right? So if my decimal point is right here, I divide by 100, 432.00, and now I am no longer in a percent. I am now back to a decimal, and that's exactly what you do. And that's exactly what I wrote down here. To convert, you divide your percent by 100, and you can do that in a calculator. Or, kind of what I was showing you without using a calculator, just move your decimal point to the left twice. Okay? And that's it. That's all you have to do in order to get a percent to a decimal. So let's actually see some examples of this. All right? Convert the following percents to decimals. Okay? And we're just going to kind of run through these, and I will give you attempts to try. So I'm going to start here. My decimal point's right here. Okay? So again, I'm going from a percent to a decimal, so I'm dividing by 100. I can show you in a calculator what that looks like. So I start with my percent, that's 43%. I'm going to divide by 100, and look, I'm at 0.43, which is what we would have got if we just moved to the left twice, right? So you can see how the math is working out. Again, same thing right here. This is a percent, and now it's a decimal. Okay, percent. Haha, no longer you're a percent. You are now a measly decimal, 3.431 as a decimal. Ain't nothing but a little thing, okay? Not too bad. So I would like you guys to try number 1 and 2. Convert these guys from percents to decimals. Go. All right, let's see what you guys came up with. This is what I came up with. Again, to the left twice. All right, again, here's my decimal, to the left twice. 3.03, this one's 0.612. And there you go. That's it. Not too bad. So now, let's see it in the context of an actual homework problem, something you might encounter on your homework, okay? So, let's see it. This is a homework question that you'd see on level 3. What is 82.33% of 25 seconds, and good old-fashioned rounding comes back. Round your answer to the thousandths place. So I'm going to show an example, and then I'm going to let you try one. Okay? So again, what is 82.33% of 25 seconds? So you're starting to probably see, hopefully, how level 1, 2, and 3 are all like interconnected together. Again, I gotta, just like I did with level 1, I convert my fraction to a decimal before I multiply. This time, I'm converting my percent to a decimal before I multiply. And why am I multiplying? Well, this of right here. Okay? I know I'm going to multiply these numbers. I know I'm going to multiply by 25. And now I got to get this guy to a decimal. What is that as a decimal? Move it to the left twice. 0.8233 times 25. Now we use our calculator. Let's throw that in the calculator. 0.8233 times 25. And I get that disgusting looking number. Nice. That is to the 10,000ths place right now. But I want my answer in the thousandths place. Okay? So again, I find my thousandths place. Hey, it's right here. Okay, tenths, hundredths, thousandths. I look to the right. That's 5 or larger, so this guy goes up to 3. So my final answer is 20.583. And what were my units? Seconds. And then we're done. That's not a 5, that is a horrible looking S. Okay. And now, for you guys, I want you to try, what is 193% of 80 days? Round to the nearest whole day. Refer to your rounding notes on what that means. And go. Alright, we are back. 193% of... I don't even know what I tried to do there. Look how beautiful that F is, right? It's got like a twirl in its hair. It's like, man, that is the best looking F on the planet. That F puts all the other F's to shame, but unfortunately we got to convert our of to multiply, so goodbye F. And 193% as a decimal is 1.93. I multiply these guys, 1.93 times 80. I end up getting 154.4. And I want to round to the nearest whole day. So again, my whole numbers, that means round to the ones place. Here's my ones place. I'll look to the number on the right. It's less than 5. So I keep this as 154. And our unit was days. We are good to go. Not too bad. Now let's move on to reducing. Reducing. And first, before we do that, we need to talk about something called divisibility. Okay? Divisibility. What is divisibility? All right, well, here's a definition of divisibility. It's to be divisible, and I guess it'd help if you could see it. So divisible means capable of being divided without a remainder. So for example, 8 is divisible by 4. Right? I do 8 divided by 4, I get a whole number of 2. But 8 is not divisible by 3. 8 divided by 3, it's not a whole number. It doesn't give me something back. I will get a remainder. I'll get 2 and some change. Okay? So that's divisibility, and that's a key concept when it comes to reducing. Okay? So how can we tell, like if I took a number like 3093, how could I tell if it's divisible by 1 through 9? Well, I actually am going to, if I haven't already in real life, I'm going to pass out to you guys a nice little sheet that covers all the divisibility rules, so you don't have to write them down, okay? But let's take a look at them online real quick. Some of the divisibility rules are right here, okay? So it says a number is divisible by 2, 3, 4, 5, and then it gives you the reason right here, okay? So for example, you can tell if a number is divisible by 2 if the last digit is 0, 2, 4, 6, or 8. AKA, if the number is even, it's divisible by 2. How can you tell if it's divisible by 3? Well, that's if the sum of the digits is divisible by 3. So if we're looking at 3093, I would have to add up its digits. So that'd be 3 plus 0 plus 9 plus 3. Well, that would be 15. And we know that 15 is divisible by 3. So 3093, it turns out, is divisible by 3. What about 4? This will be the last one we do. What about 4? If the last 2 digits are divisible by 4. Well, 93 are the last 2 digits, and 93 is not divisible by 4. So 3093 is not divisible by 4. Okay? And we're going to go over those a little bit more in class, and we can tomorrow when Group B comes back. Okay? So let's get back to this. Okay? So we'll go over that divisibility sheet, and it won't be too bad. All right? But that divisibility sheet, I'm going to upload it into your Schoology folder so you can at least have access to it as a PDF. Okay? But there will be a copy waiting for you in class. All right? Let's kind of take a quick look at it too. This is what it'll look like when you get it, just like what we saw. Right? And so I didn't want to take up so much time going over all the divisibility rules and everything, because really what I want us to get good at is just reducing, right? Reducing is the key, and divisibility helps us unlock, or I guess divisibility is the key to unlocking the secrets of reducing, is what I'm trying to say, okay? So when you're reducing fractions, guys, this is our fourth skill, just find what both the top and the bottom are divisible by, and then divide them, okay? So for example, 4/8. What are 4 and 8 divisible by anything? Well, they are divisible by things. They're divisible by 2. So since I know they're divisible by 2, I'm going to divide the top and the bottom by 2, and I get 2/4. But looking at 2/4, is it still divisible by 2? Absolutely. I can still divide the top and the bottom by 2. No problem. I'll end up getting 1/2. Now, some of you might have been able to look at that and be like, hey, I know that's 1/2 right off the bat, okay? Because you notice, oh, top and bottom are divisible by 4, and you get 1/2. So either way, it'll work out the same, okay? But try to use like 2, 3, 4, 5. Use easy, smaller numbers to kind of break down these bigger numbers, okay? What about something like 14/392? That's kind of wild, right? Well, we know it's divisible by 2 because the bottom's even and the top's even, so that'll help us out. However, it might be divisible by something else, like maybe 7. Well, I know 7 can go into 14. I don't know if 7 can go into 392. So there's kind of a couple ways I can check and see. First of all, I can just do 392 divided by 7, and hey, I got a whole number. It is divisible by 7. I could also use my divisibility rules, right? Well, for 7, it's kind of a lot, so follow along the best you can. You're going to cross off the last digit, double it, and subtract, okay? If the new number is divisible by 7, the original number is divisible by 7. Okay, so basically what that means is I'm going to take this last digit, I'm going to cross it off, then I'm going to double it. So 4, okay? Doubling 2 is 4, and then I have to subtract whatever's left over by what I doubled. So I have to do 39 minus 4, and I get 35. And then I say, hey, is 35 divisible by 7? Because if it is, this original number, 392, is divisible by 7. And yeah, 35 is divisible by 7. So what I'm going to do, since we can clearly see the top and the bottom are divisible by 7, I'm going to divide top and bottom by 7. So 14 divided by 7 is 2. We saw on our calculator this was 56. And look again. Can I reduce that further? Well, yeah, it looks like the top and the bottom are even. So 2 divided by 56, divide the top and the bottom by 2 now, I get 1 over 56 divided by 2 is 28. So this guy is 1 over 28 reduced. They are the same fraction in terms of value. That means if I do 14 divided by 392, I get that decimal. But if I do 1 divided by 28, I get the same decimal back. They are the same value. Okay, they are just written differently in a more simplified term. So what I'd like you guys to do is I want you to try to reduce number 1 and number 2 right here to the best of your ability. And go. Alright, and we're back. So, looking at this first one, I know right off the bat the top and the bottom are divisible by 2. It's pretty nice. What if they're divisible by something higher, like 4? Well, if the last 2 digits are divisible by 4, then it's divisible by 4. Well, that doesn't really help us too much. So I guess we gotta just try 64 divided by 4. And hey, that did work out. So I'm going to do the top and the bottom divided by 4. So 24 divided by 4 is 6. 64 divided by 4 is 16. And I can keep going, right? It looks like I'm not done. Divide the top and the bottom by 2. And I get 3 over 8. And that guy is done. Okay. 13 over 25. You actually can't do this one. This guy can't be reduced. Okay? Can't be reduced. Why not? Well, there's nothing that both of these numbers are divisible by that's in common, right? Especially 13. Now, 13 is a unique number because there's only two numbers that are divisible or 13 is only divisible by two numbers. It's only divisible by 1 in itself. And we actually call that a prime number, okay? So a prime number is actually just a number. So this is a quick definition. Prime is a number divisible by 1 and itself. And so if you guys run into a prime number, unless the other number is divisible by that number, so in this case, if 25 was divisible by 13, you're probably not going to be able to reduce it. But double check, okay? Double check. Just do 25 divided by 13, and hey, or 25 divided by 7, 7's also a prime number, and see if they're both divisible. I also included, on your divisibility rules, I included a list of the prime numbers. Well, 1 through 100, okay? So if you see any of these bad boys, that should help you with reducing. This is Mr. Knight signing off. Good luck on your homework, and have a good one.